Okay, this is the first video in lesson 3.3, and we're looking at the Bolzano-Weierstrass theorem. Suppose that we have a sequence, we'll call this sequence 3.4, has x sub 1, x sub 2, and it goes on in sequence x sub n, and that continues on. Our sequence numbers, then subsequences could be x sub 1, x sub 3, x sub 5, which would be the odd numbers in the sequence, x sub 2, x sub 4, x sub 6. So they split off into subsequences. Okay, so let's look at numbers here, such as a sequence 3.5 in the book. We have x sub 1 equals 0, x sub 2 equals 1/2, x sub 3 equals to a negative 2/3, and so on. That continues on. So here we have the sequence x sub n equals to negative 1 to the n power times 1 minus 1/n. All right, and so if we were to say n equal 1, where n equals 1, 2, 3, and that continues. So if we look at x sub 1, where n equals 1, this would be x sub 1 would be negative 1 to the 1 power, 1 minus 1/1 would be negative 1 times 0 equals 0. And then n equals 2, that would be x sub 2 would be negative 1 squared times 1 minus 1/2. Now this becomes positive. 1 times 1/2 is 1/2. And then and 3 would be x sub 3, and that equals to negative 1 cubed times 1 minus 1/3. Now this becomes a negative, and we get 2/3 from that, negative 2/3. So now we start at 0, 1/2, negative 2/3, and so on. N equals 4. We got x to the 4th, x sub 4 rather, negative 1 to the 4th, 1 minus 1/4. Now it becomes a positive again. And then this would become 3/4. So now we get 3/4, and so on. And so this continues. If we continue with the sequence, so what we have here is 0, 1/2, negative 2/3, 3/4, and this sequence continues. If you went with n equals 5, you get negative 4/5, and negative 4/5, and n equals 6, you get 5/6, n equals 7, you get negative 6/7, n equals 8, you get 7/8, and so on in the sequence. So you can see that the sequence oscillates back and forth between positive, starts off at 0, goes positive, goes negative, positive, negative, and it doesn't converge. But if you were to divide them into subsequences, we take 0 and then negative 2/3, negative 4/5, negative 6/7, and so on. And then the other subsequence would be positive numbers, such as 1/2. Of course, 0 is neither positive nor negative, but we put 0 in with the negatives. 1/2, 3/4, 5/7, 7/8, and so on. That continues on. Now, the subsequences, we notice that they're converging. This subsequence is converging to -1, the positive numbers. That subsequence is converging to +1. So we can say that each of these subsequences are convergent, but the original sequence is not. But the original sequence is not. The Bolzano-Weierstrass theorem, Weierstrass theorem is basic that it establishes. Theorem is basic that it establishes the existence of a convergent subsequence. Existence of a convergent subsequence. So even though the original sequence is not convergent, you can find somewhere, some subsequence, some subset, if you will, that is convergent. So therefore, Theorem 3.7 in the book, Theorem 3.7 in our textbook, states that the Bolzano-Weierstrass, I'm just going to abbreviate it, BW theorem, is any bounded infinite sequence of real numbers contains a convergent subsequence. Contains a convergent subsequence. Okay, and so we're going to learn more about that in the next couple of videos, and go over some homework examples of some homework problems as well. Alright, and that concludes this video.